Tēnā koutou koutou. Good evening, everyone, and welcome to our panel discussion today about comfortable living in the times of decarbonizing our economy. We're going to be talking today about electrifying everything in the paradigms of 5 fabrics. So I made one little slide that doesn't see me. Damien, can you? Probably a little bit too far. There you go. First technical difficulties. Anyway, my name is Natalie. I'm a strategy and business modeling consultant for power industry, and I'm going to be your host tonight. Before we get into any sort of discussions, we have to do a little bit of housekeeping in case of emergency. We have to get out of here. We're going straight out of this door or the door to my right. The gathering point is 100 meters down the street at the car park lot. The restrooms are again to my right, going to the exit and right under the stairs. And I'm going to make a little introduction about the 5 canvas all together. Here we go. That's me. We already half part through the introduction. I'm going to get to the meat of it. So we're talking, oops. We're talking about the 5 fabrics first, or fabric fifths. The concept was born in the UK about 5 years ago. So it's highly advertised by the Oxford scholars. And the concept is about electrifying first, or maybe making everything energy efficient first. For those who are curious, there are 5 of them altogether, and the remaining 3 are around tracking behavioral changes of people, or introducing policy first, or maybe creating market or any other structure that would promote decarbonization. So we're here talking tonight about decarbonization and what you're going to do. Do you get energy efficiency first and then electrify, or do you electrify first and then become energy efficient as you go in the context of the residential houses? We're going to have a very great selection of speakers today. I'm not going to name them all. They're going to be one by one. So we have representatives from passive house side. We have very high enthusiasts of electrifying everything that moves. There you go, that's the one. We have representatives from our local distributor grids. We have representatives for those who provide us with equipment and materials to make our homes warm and solar. And we have also architects and city council representatives to really cover up every aspect of this topic. I'm going to pass the floor on to Damien. He's our local Christchurch lead for the Passive House Association, and he's going to walk you through the concept of the passive house. There we go. Sorry. After all, we're going to have a little reception out there, and at the very end of this, we're going to have a Q&A. I will come to you, and you feel free to ask the questions. So hold your horses till the very end if you can. Thank you.
And don't forget this kit out here. So our sponsors and suppliers, support them and come and see their gear. Right, let's get cracking. So why passive house? Well, just think of being in the warmest house you can imagine, and think of your family also being in that house. Think of your friends, the whole community, in fact. Think how much better that would be for everybody. Passive house provides futures for people to thrive. When this whole event came about from a few conversations with Mike Casey, and the tension between price, cost, value and comfort, which I call the cost of choices crisis. So myself, I'm Damien McGill. I've got a company called Healthy Home Corporation. Ultimately, just want to build better homes. I'm an engineer, so that comes from the engineering perspective. And the thing I like to do most is celebrate the success of people's homes. My brother and sister-in-law have a cider and wine business, so there's always some able Chardonnay available for a good house.
Damien, can you speak into the microphone?
Oh, like that?
That's going to be great,
okay.
Thanks.
So we need passive house. So B2 of the building code, I can hear myself echoing. B2 of the building code says that our houses should last at least, or not less than 50 years in a roundabout kind of a way. I've got a couple of structural engineers in front of me, so I've got to get the technology right, talk right. And a lot can happen over that time. And our building code dates back from 2004, and effectively our housing that's been built is already out of date as it's being built. We're not considering our health and well-being, and we're not considering the changing climate. Every year, I get asked by staff to talk to them to get an article going in the paper about whether we should leave our heat pumps on in winter or whether we should turn them off and on as we need them. And actually, Julie got asked this year as well. This year I said it's a stupid argument. The whole point of having a heat pump is to be warm and comfortable, not to be trying to be cheap with your bills. So imagine having a house where you didn't have to worry about how long your heat pump was going or how much air was leaking out of it. That's what passive house is about. So passive house is a voluntary international best practice standard for the best quality buildings that we currently can design that use a hell of a lot less power than our standard buildings to keep warm. Passive house works right across Aotearoa. It works from Kaitaia to Bluff. It works from Stewart Island to the Chatham Islands. It just works. So the technical definition for passive house is a building for which thermal comfort can be achieved solely by heating or cooling of the fresh air volume required to provide good indoor air quality. So basically, if you take anything away from today on the passive house side of things, passive house is all about comfort. The passive house is a fabric-first approach to achieving healthy and comfortable buildings. It's a clearly defined standard and a quality management system that produces buildings that deliver on all aspects of occupant well-being while consuming very little power. Passive house provides good buildings to help us live great lives. So first passive house was built in 1990 in Darmstadt, Germany, and Passive House Institute was founded by Dr. Wolfgang Feist in 1996. There's another guy too called Bo Ablinson. I think he's a Canadian guy, but he's not talked about quite so much. First passive house built in New Zealand, it was in 2012 in Glendowie in Auckland. It just sold in the last month for the first time. It gained a premium about 15% above what the market expectations were. So passive houses operates all around the world. It's one standard. It's a lot easier if we're all using one building standard. I can be designing or engineering a house in the UK, so we can share all that knowledge. It's not just in the New Zealand context. It's thousands and thousands and thousands of people, could be millions of people all over the world sharing knowledge of the same standard. And, you know, over time, more and more people are getting passive house. You know, it's the next sure thing. It's the next overnight success. It's only been going for 35 years. In New Zealand, we're doing our thing. We're up to somewhere around 200 odd buildings in the passive house space. And those buildings can be built out of pretty much anything you like, as long as you make the metrics. Timber frame, SIPS panels, insulated concrete forms, even straw bale. When people think of passive house, they're generally thinking of passive house classic, but there's a few other standards. So the passive house classic that everyone's familiar with is for new buildings. There's the Interfit standard for retrofit buildings, and there's also a PHI low energy building standard as well. So let's get back. So you'll see under the passive house and Enefit thing, there's 3 bars, classic, plus and premium. So the plus and premium are the energy generation side of it. And I think Jonathan can elaborate on how that works a bit later on. So my take on the 5 passive house principles: spired insulation, thermal bridge free, wonderful windows, heat recovery ventilation, airtight always. And that needs to be wrapped up with energy modelling. And that's a design stage thing, not a box ticking compliance exercise, as H1 is. So effectively, I only need 6 things. You only need to remember 6 things to build better buildings. That's it. To build better buildings for all of us to thrive. How do we know passive house works? 25 years of testing. Actually, if we take 1990, 35 years of testing and refining. Every certified passive house is checked, tested and verified both through the design process and during construction by a third-party certifier. Passive house provides homes where people thrive. Something, if you're looking to build, to have a chat to your builder or your designer about. How easily is it to keep your house between 20 and 25 degrees? Can you test drive the house before it's built? That's what energy modelling can do. What's your continuous ventilation system? Opening windows doesn't work. And can you add solar panels during there, or can you add them later on? So, and this is where I'm going to struggle with it on the lines, but Passive House Institute New Zealand has been set up to provide the very best, provide advice and help bridge the performance gap between our current building standards and where we need to go. We provide education, events like this, conferences, one-on-one training. We collaborate with industry and we help lobby and promote stuff that's going on. Work with suppliers. We promote what we do also with suppliers, and there's lots of different trade groups and stuff that are involved. And we provide training through the Passive House Training Academy. So Passive House is based on fundamental laws of physics, be it classical or quantum, but it's technological application that doesn't require rocket science. In fact, anyone can understand it, and more importantly, anyone can contribute to making it happen. So that comes from Dr. Wolfgang Feist, who earlier today put a message on about this event. He said, with very low loads for heating and cooling, it's easy to electrify a passive house or an Enefit renovation. Everything you need is already available in the market at affordable prices. What must happen in parallel is the installation of PV systems and wind generators so that most of the electricity can come from these renewable energy sources. These combined measures will reduce dependence on fossil fuels, create local value chains, improve comfort and longevity of the buildings, and reduce climate gas emissions significantly. I just think it's cool that someone that invented a standard from Germany is following what we're doing in little old Aotearoa. Join us, get involved, and help us provide futures for all of us where we can all thrive. Thank you.
I've got 2 hands. 1, 2. I thought I'd just wander over and just... Hello, my name's up there, and so is my company name. So you can check me out online or come and talk to me afterwards. I've done all sorts of stuff, and most of it I'm pretty proud of. I'll do the slide then, Damien. There we go. Given that Natalie and Damien stolen a little bit out of the fabric arena, and Mike's got a huge mountain to go through afterwards, I thought I'd go really broad and perceivably disconnect from the subject, but then hopefully get narrow again and bring myself back to it. Everything that everyone's going to be talking about is directly related to cogs, and let's call those planetary boundaries, and they're all part of a wheel, and let's call that a planetary system. So, oh, back, stop. You need some training. 2009, a bunch of top scientists, led by the then director of the Stockholm Resilience Centre, Professor Johan Rockström, first proposed planetary boundaries. And these are quantitative assessments, safe limits for human pressure on 9 critical change processes. Raise your hands if you know what they are. Goody gumdrops. So there are your 9. There are 7 in the first place and 2 were consequently split. And you probably want me to tell you about how they connect to the built environment, which is, I guess, what we're all into here. So climate change the industry accounts within cities for over 70% of CO2 emissions, buildings of 3 primary sources with transportation and energy production being one of the top 3. Second boundary, novel entities. This includes plastics. So within the built environment, pretty easy to understand that building material supply chain causes pollution. Stratospheric ozone depletion. How do we affect it from the built environment? Well, though aircon refrigeration gases have been largely regulated, they're still being used illegally in parts of the world. Atmospheric aerosol loading. Within construction, our construction and demolition practices produced articulates and air pollution. Ocean acidification, got sewage and urban runoff, affecting that from the built environment. Modification of biogeotechnical flows, stimulated by fossil fuel production and combustion, freshwater change, impacted by concentrated urban water runoff. Land system change, impacted by unsustained or unsustainable production of timber products, and biosphere integrity, impacted by urban development. From the Stockholm Resilience website, word for word, crossing boundaries increases the risk of generating large-scale, abrupt or irreversible environmental changes. The impacts of these changes will not necessarily be immediate or drastic, but together the boundaries mark a critical threshold for risks to societies and the biosphere that we're part of. So, next slide there. And assessments have been undertaken on the state of the planetary boundary since 2009. 2009, 3 of 7 assessments, 3 of the 7 boundaries had been crossed, and this included climate change. By 2015, 4 had been crossed. 2023, at that point, 2 of those boundaries were split, and 6 of the 9 assessed had been crossed. And by this year, 7 of the 9 have been crossed. And currently this is only leaving stratospheric ozone depletion and atmospheric aerosol loading. So Arup, who are quite a clever bunch, in 2021 released a report designing for planetary boundary cities. And within it, they considered the 9 boundaries, and they considered how the built environment was detrimentally impacting those boundaries and what could be done to bring about positive change. Next slide, cool. So they worked and developed 20 regenerative actions that are considered can be implemented within the built environment that will in turn bring about change for all 9 of those boundaries. Next slide, please. So Professor Johan Ruckström, who's now current director of the Potsdam Institute for Climate Impact Research, and the centre itself since 2024 has been using the planetary boundary framework for its planetary health check. And their 2025 report was published last month. And in its executive summary, the 2025 PHC report, Planetary Health Check, concludes that 7 out of 9 planetary boundaries have been breached, with all those 7 showing trends of increase in pressure, suggesting further deterioration and destabilisation of planetary health in the near future. I know that's good news to you all. Next slide. And in June this year, just a few months before that report came out, Ruckström was presenting as the Frontiers Planet Prize Chair of Jury of 100, the 100 being 100 top scientists that they'd rounded up. And in a 15-minute presentation, rolled out those little beauties. So we are in danger and outside the safe operating space. Happy days. Then the second one on the list, and the third one, okay, crowd participation at this point. I'd like you to all say out loud after I count 3 what it says on the third line. 1, 2, 3. Not bad. Speed and scale, only currencies. There's no linear pathway to a safe landing. We've got to speed up. And Ruckström also in that 15 minutes gave us a new definition of sustainable development. So the question is, are we being the best stewards of the planet? And the question for all of you sitting there is, are you being the best steward you can be? Global footprint. If the whole population of the planet went about using ecological resources the way we do in New Zealand, we'd be all out by April the 30th. Oh, that was earlier this year, wasn't it? Oops. So it must be clear that we need to get the next stage right. And before Mike speaks, I'm going to come back from that broad into the narrow and indicate that within the sector, it's making sure that from the cradle to grave of construction, development, renovations, refurbs, call it what you like, working with the building, we've got to get it right. And we've got to optimise getting it right by using all the tools we have to hand. So fabric first approach, bingo. Say goodbye to the gas hob, water heater, log burner. Say goodbye to sieve-like walls, floors, roofs. Say goodbye to the leakiness of your envelope of the fabric. Passive house all the way. Or is it? So we've got 30,000, according to the Green Building Council, 30,000 new builds going up every year. 30,000. So why aren't they all passive house? Cost to build, have been demonstrated elsewhere in the world in a few occasions, but it has been demonstrated that they're as cheap to build as co-compliant homes. So let's get on with it. Fabric First is a straightforward choice for new build, and particularly if PV and battery costs are high, upfront carbon is high, and installation costs are low. So they're all changed, then it's not a straightforward choice. So we ideally need to make provision for renewables at the same time and then supplement them afterwards if our budget doesn't allow in the first place to do so. So the focus of Fabric Fifth, I guess we could say, primarily lies with retrofitting, sorting out the crap that's still standing. That might be our next one, thank you. Not there yet, but that's my house. It's nice, isn't it? So our existing stock is 1.85 million homes. Green Building Council have identified that 800,000 of them were built before 1978, which probably means they haven't got any wall insulation. And I found most of them during the earthquake rebuild. But they're looking at a roadmap highlighting that we need to deep retrofit an initial project of 300 with 200,000 on the backside of that to be fitted out. 200,000, Pete, that's a lot of work, isn't it? Do you want some of that? Of course do. So getting it right, 200,000, we're building 30,000 new ones a year, 200 is going to take us quite a while to sort out, plus the 600 after that. So we need to have efficient use of all of our tools, and modelling has to be their centre stage. Identifying 200,000 and 800,000 in an economic manner has to rely on some form of sophisticated criteria to identify where that work is going to bring greatest benefits initially in the programme. Potentially involve the use of a retrofit coordinator and a whole pile of stakeholder involvement, training and policy change. And fundamentally, the first and fifth response simultaneously. So how much time have I got to talk about my own house? Excellent. That's my house. I led the design and the build. I moved in 2 years ago. I used SaveBoard, a re-leveling system. I put solar panels on the top. Tom, how many have I got? About 20. I haven't seen them. They're up there somewhere. One thing I'll do, I think, is probably re-pitch that roof so I've got extreme exposure to the north. But it's nice like that, isn't it? Thanks, Pete. Thanks, everyone.
All right, tēnā koutou e te whānau. Quick show of hands. How many people in this room want shit to be better? That's why I say e te whānau, we're all part of the same family. We might disagree a little bit on what is going to make shit better, but we all want shit to be better, right? Now, I want you to give me a warning at the 5-minute mark and then again at the 1-minute mark. Just yell out. I'm used to it. But yeah, kia ora everyone. My name is Mike. I run an electric cherry orchard about 5 hours drive from here down in central Otago. We do grow the best cherries in the world, but of course, what I have become very well known for is the fact that we run our farm entirely on 21 electric machines. Yes, I am all about electrification. I have been asked to be very spicy tonight in terms of talking about electrification over fabric improvements in homes, and I intend to do that. But again, we're all part of the same whānau. I know in every single slide, someone in this room is going to go, yeah, but in their mind. And when you do that, I want you to hold on to it. We're going to have a panel discussion afterwards because there is so much nuance that goes on with this debate that ultimately I can't cover everything in 15 minutes. I'm also the CEO of an organisation called Rewiring Aotearoa, which is all about electrifying the whole of the country very, very quickly, talking mainly about households, but also farms, also small businesses, and eventually absolutely everything. We aim to build the cheapest and most renewable energy system in the world, and we're going to do that by concentrating on the low-hanging cherries, everyone. Good joke that, isn't it? There are 10 million fossil fuel machines in New Zealand, 700,000 that are close to impossible to electrify right now, right there. The big machines where the technology doesn't exist, or maybe the technology exists somewhere, in the world, but it's hardly economic for us in New Zealand to go and electrify these machines. There's 1 million machines in New Zealand that are almost ready and 8.5 million machines that are ready to electrify right now with today's technology off the shelf in New Zealand, where we will save a bucket ton of money. There are 64 hot air balloons in New Zealand. The hot air balloons are not a reason for us not to, they are not a reason for us to delay electrification of our country, right? It's as simple as that. There are about 1 million machines that are almost ready. Our utes, some of our smaller tractors, our boats, the 50 electric dump trucks that we have up in Auckland, right? There is a number of machines that require heroes, electrification heroes, to start electrifying these things in New Zealand, burning far more energy than what we would consider to be reasonable, or far more willpower than what we would consider to be reasonable. And there's 8.5 million machines that are ready to electrify now. And where do most of those machines exist in New Zealand? In the home, 100%, right? They account for about 25% of New Zealand's gross emissions. It is a ridiculous amount of emissions that we emit every year that we no longer need to. And we're spending a lot of money doing so. Now, the important thing is I come at this from a slightly different angle to the built environment, or people that are professionals in that space. I like to include the car. When I think about the customer, I think of their bank account and all the money that leaves their bank account to pay for energy. And as soon as we include the car in this, along with our space heating, the way we heat our water, the fridge, the light bulbs, and everything else, it starts to paint a different picture on the ROI for the households of New Zealand. Electrification is the efficiency that we have always been looking for, right? When you have a fossil fuel home that runs off gas and petrol, and then you compare it to a fully electric home, it uses about 1/3 of the energy to do the exact same job. Pretty remarkable. And if we look specifically at our cars, when you put a litre of petrol or a litre of diesel in your car, about 21% of that energy is actually used to push the car forward. Everything else is wasted heat, wasted noise, vibrations. When you put electricity into an electric car, nearly 90% of it gets used to push the car forward. They are far more efficient machines. In fact, they're so efficient, when you look at the largest electric vehicle on the market in New Zealand, a Ford F-150 Lightning that they convert in Australia and bring over here, it uses less energy than a Honda Jazz. Isn't that remarkable, right? This is energy efficiency right here. And this is what it translates. If we have a look at the cost for petrol per litre, and we translate the cost of electricity and running an electric vehicle off the grid in terms of a per litre equivalent, and we look at it when we put solar on the roof and power our electric vehicles through that, you can see just how much savings New Zealanders are leaving on the table by continuing to put foreign-sourced energy into their cars. And what's really interesting, of course, is that 85% of energy put into EVs in New Zealand come from sockets in the home. Yes, the car is a massive part of home energy bills moving forward. Then we can look at our heating. Very simply put, if we put wood burners in homes, about 65% of the energy in a log is used to heat the home. The other is wasted in things like light and noise and heat going out the chimney. When we look at gas heating, it's about 80% efficient, which actually sounds pretty efficient, doesn't it? Of course, you all know this. Heat pumps, 300 to 400% efficient, right? Remarkable returns on investment. And when you look at this, you can sort of see the daily requirements of energy use, but based on the different types of heating appliances in the home. It is remarkable how much of an impact a heat pump can make over, say, gas or LPG heating in this country. And of course, that translates to the overall lifetime cost of an appliance. If you buy a gas heater for your home, you're paying significantly more money over the lifetime than if you pay for an electric equivalent. Then we've got our hot water. Hot water heat pump just over there. I encourage everyone to have a look at that in great detail. But again, gas hot water heating, about 80% efficient. Hot water heat pumps, about 350% efficient. When you look at the amount of energy required to heat water with a hot water heat pump per day, it is considerably less than a gas equivalent and considerably less than an electric resistive equivalent. And again, the prices for lifetime ownership of these machines is considerably less. Then we look at cooking. 30% efficient. And with that, we're putting all sorts of bad chemicals out into the air, nitrogen dioxide being one of them, that have a lot of serious health impacts. 70% of that is wasted compared to about 78% efficiency of an induction cooktop. Remarkable savings again. And again, when you look at the energy use in the home, not as higher amounts of energy are used for cooking, but it is still far more efficient. Because it uses less energy, at the moment, we're not at a point where we can say induction cooktops are going to be cheaper than gas cooktops over their lifetime, especially on the reticulated gas networks in the North Island. But with the fact that we're running out of gas, that is changing very, very quickly. Another way of looking at this is the electric machines in the home. If you choose an electric machine in the home over a fossil fuel equivalent, the number of return flights between Auckland and Queenstown. We always talk about climate action being in terms of maybe eating less red meats, drinking less milk, flying less. The number one way that the households of New Zealand can have an effect on climate change is to make sure they go fully electric. We must electrify everything. But what happens when we electrify everything? Our power bills go right up. Yes, because we consume way more electricity. And this is the breakdown of a power bill in New Zealand. You're paying about 35 cents a kilowatt hour for what we call delivered energy to the home. Half of that is generation at our large power plants, and the other half is all the other stuff that we have to pay for to transport those electrons from the power plants to our homes. And just to give you some stark contrast, when we finance solar panels on our rooftops at 5.5% interest rate, so a standard mortgage interest rate, nothing clever, it works out that those panels will generate at about 13 cents a kilowatt hour. Remarkable savings opportunity. In fact, even if you look at gross savings and you take out the capital repayments and the interest repayments on a 9 kilowatt system, the average typical home in New Zealand will still save $1,000 a year. That is $3 a day return from day one when you finance solar panels on your rooftop. It is by far the best ROI of any home improvement that a family can do within our country. We talk about embodied carbon emissions. That comes up a little bit. The important fact to remember here, again, with New Zealand solar yield, it's very important that we use New Zealand data here. A solar panel will create 32 times the energy that it takes to make it over its lifetime, right? It is a really significant improvement on energy production in our country. And one of the other things to think about is that even in winter, a 9 kilowatt system will generate the same amount of energy as 1 tonne of coal. And I know, because we're all part of the same whānau, that we're incredibly embarrassed about the amount of coal that we burn for electricity in New Zealand. 120,000 homes with a battery, right? That is larger than the peak response of our largest hydro dam. A lot of a little is a lot. The systems improvements from electrifying our households are so significant that we need to all band together and figure out how to make this happen very, very quickly. See, New Zealand's energy system isn't actually very renewable at all. We like to talk about how renewable our electricity system is while sweeping under the rug how unrenewable our overall energy system is. And it's expensive. Collectively, you and I spend $55 million a day on fossil fuels. Isn't that a remarkable amount of money? Just electrifying all the homes in New Zealand, including the cars, putting some solar panels on the roof and a battery in the garage, will save our 2 million homes about $29 million a day. All right? That is so much money. By 2040, if we do this and we commit to doing this, that's $100 billion, which is so much that no one knows how to contextualize how much money that is, so I've done it for you. We could not build hospitals fast enough to keep up with the household savings. This is not money that's going to Christopher Luxon or Treasury. This is money that stays in our wallets in our communities. This is why I get so passionate about this kaupapa. We could not build Christchurch rugby stadiums fast enough to keep up with your savings. That is how remarkable this opportunity truly is. It also shows you just how expensive Queenstown roundabouts can truly be. See, Rewiring Aotearoa was born out of the work that a chap called Saul Griffith, an Australian, did in America, and then moving back to Australia and starting Rewiring Australia. And he makes climate action really simple for everyday people to understand. I want you to make 6 good decisions over the next 20 years when it comes to the machines in your life. I'm not asking for immediate action, but the next time you need to replace a machine in your home, that machine needs to be electric. It needs to be electric for the climate, it needs to be electric for our country, and it needs to be electric for your wallet. Now, how many people had a but if thought? 1, 2, couple of you, good. Hold on to those, because I can't wait for this panel discussion when we can go into a lot more nuance, because I don't have enough time to go on to all the nuance over the phone. But if there's one thing I can ask you to do, it's I want you to electrify everything in your life. And once you've done that, well, then I want you to electrify everyone in your life. Thank you very much.
Kia ora. I'm Pip Newland. So I'm the head of sustainability risk and insights. So we do all the future energy scenarios at Orion, and I also have the fun task of looking after the market and customer innovation team. So they do all the stuff that looks about how people use the energy and how that affects the assets that we're actually investing in. So just a little, and apologies for those of you who already know this, but a wee quick bit of background about Orion. So we are the lines company, so the electricity distribution business for Central Canterbury. So we cover Christchurch, we cover the Selwyn district, and we cover all of the Christchurch district as well, including Banks Peninsula. So we've got it's actually 229,000 odd connections now, about 8,000 kilometres of lines. We're a linear infrastructure company, so we own lines and cables and kiosks and substations and all that kind of stuff. We are effectively an electron courier, so we invest in that infrastructure. And probably the thing to bear in mind in the context of this conversation is that infrastructure is two things, really. One, it's owned by the community. So we are owned by effectively the City Council via CCHL and the Selwyn District Council. And the other thing is that infrastructure is it's an asset, and it's a carbon sink, effectively. So every piece of infrastructure that we own carries an embodied carbon footprint with it. So the better that we can design our network to change how people use their electricity, and the more efficiently they can use their electricity, the less infrastructure we build, the less carbon goes into it. So there's a little bit of a trade-off in there. So I'm just going to carry on. So the other thing to bear in mind is that Orion in various forms has been around since about the 1900s. So there's been a few transitions that have happened during that period. And that's probably one thing to recognise about this community in particular, is that we're really good at transitions. So first of all, obviously moving from that coal, gas and steam in terms of our local generation. Then we moved into electrification of home heating. And now we're moving into this new period of time with redistributive systems. So what does that look like for us? Sorry, I'm going to jump. Oh, no, that one's not in there. Sorry, I'm going to go back. So redistributive systems. If you think our network traditionally has been built in a linear system. So it takes it from generation in central places, it transports it through the transmission system, thanks Transpower. It gets converted into residential and business friendly voltages, and then we transport it to your house or your business. So traditionally it's gone one way. And now we're actually in a position where the technology has evolved enough that it can travel back the other way as well. So this opens up a whole raft of opportunity for communities to be able to generate and share electricity in a way that isn't constrained by central generation, and actually enables them to be more resilient and produce more affordable electricity within their own energy ecosystems. So you're moving into that kind of model. So that in itself then lends itself to being able to manage this transforming system. We call it the trilemma. So that balancing of energy equity and affordability, energy sustainability. So how is it generated? How much carbon is associated with it, and energy resilience. So we really need to think, and when I'm talking about energy resilience, it's like, is it there all the time when you need it? So when we make investment decisions as a business, we're always thinking about balancing these three things. And a truly sustainable system does that really well. And consumers and the way they use their electricity and the things that they use their electricity within play a really big part in balancing this trilemma. It can't just be done from one party within it. So just leading into that a little bit, it's not all about generation as well, and that's sometimes what people miss. We talk about both supply side and demand side when it comes to energy. So this is a pretty typical household electricity demand. I've pinched this off the ECA website. Thanks, ECA. So typically, when people use matters just as much as how they use and how it's generated. So if we are able to just shift, if you can see that little red hump, if you're able to shift when people use, you can flatten it out, and that changes the electricity mix that's actually delivered to your doorway. Because typically the way the generation stack works is that they bring on the most expensive things at the end. So if you're actually wanting to avoid using coal to generate your electricity or paying for the coal plants to generate your electricity, what you need to do is think about when you're using. Now, if everybody switches on their, and what typically happens, everybody switches on their jug at 7 o'clock in the morning and they cook their dinner at sort of 6 or 7 o'clock at night, that adds up to a peak. And we build network and we generate, and also the generators generate to service that peak. So you've got to think about what goes into that space. So I'm going to just talk about Orion now. So we definitely build network to service our peak. We talk a lot about peak load. And a lot of what our market and customer innovation team are doing is investigating demand side options to shift that red peak onto different times in the day. And that's when storage becomes a really big thing. And what do you use to store energy? People think straight about batteries. You've actually got hot water in your house. Your whole building envelope is storage. So that becomes a really important part of how we manage energy use within the system, and that can bring the whole energy costs down and also the associated carbon emissions. So just to kind of reiterate that point, that there's no kind of best fit. There's no winners here. It's actually, we need everything everywhere all at once. So we need heaps of solar generation. I absolutely agree with electrification as well. We also need lots of passive houses. We need more efficient housing stock, and we need storage associated with that housing stock. Now, if you have a really efficient house and you have an electric car and you have solar panels, all of those together add up to a really amazing energy resource that opens up opportunities for communities to share electricity so that everybody gets to participate, and it brings the total system cost down. So, because the other thing to remember in this transition process is that what typically happens is that people who can afford solar and batteries will buy solar and batteries, and people who can't won't. And the people who can't then pay the expensive electricity, and the people that buy the assets don't. So is there a way to actually improve that system transition and bring the total cost down? And a way of doing that is by building better housing stock so that those people who, even if they can't afford electric vehicles, they can still use the way they use electricity within that house to generate value for them and for their community. So, and actually I'm going to stop there. So I got very enthusiastic there, and I'm really looking forward to the panel discussion. Sorry, last factoid, sorry. Just to give you an idea of the carbon emissions associated with our infrastructure. So our operating emissions, typically around 2,600 tonnes a year. Our Scope 3 emissions, so that's building and maintaining our network, 66,000 tonnes a year. So if we're able to reduce the amount we build and change the way that we maintain it, you think about the amount of carbon savings just involved in that. So thank you.
I've got the three-hand dilemma. All right, so thanks, Pip. I'm obviously, as it says up there, Chris Doppeider. I'm a senior architect and senior associate here at Borrow the Money. I'm also the sustainability lead for the South Island. So I'm going to consider the question of fabric first or fabric fifth in the terms of carbon and global warming. And to do that, I'm going to give you a quick introduction to the different types of carbon that are emitted during a building's lifespan, and then show you some graphs that will turn this from an either or question into a both and answer, which I think is what a lot of these people have been getting at so far. So for those of you who have been living under a rock for the past 30 years, the average global temperature has been rising. You may not have noticed this being under a rock. It's currently around 1.5 degrees higher than it was in the 1800s at the start of the Industrial Revolution. Typically, 1850 is chosen as a baseline. I like to think that's when it's because thermometers were invented then. But actually, it was the point at which we, or our ancestors, started burning enormous amounts of fossil fuels. These fuels, mostly coal at first, but then oil and gas were burnt to power steam and internal combustion engines, to run the furnaces and factories, and to mechanize the means of combustion, means of production. As a result, we have the living standards of today: sleek glass and steel buildings, and as Dire Straits said, microwave ovens, custom kitchens, and colour TVs. But as the old saying goes, there's no smoke without fire. And when you have a lot of fires, it stands to reason that there's a lot of smoke. And all the smoke, which is largely carbon dioxide, ended up in the atmosphere, as did an alphabet soup of other gases: methane, nitrous oxide, CFCs, HFCs, HCFCs, and so on. And as we now know, but have conveniently ignored since 1824, gases trap the heat radiating from the Earth, creating a greenhouse effect and raising the temperature of the atmosphere. Collectively, they're called greenhouse gases, or GCHCs, and we measure these in equivalent units of carbon dioxide warming potential, which is usually just abbreviated for carbon, to carbon. So constructing and running any building emits carbon. This might be in any number of ways: loss of forest cover due to logging to provide timber, a manufacturing process for products such as cement, steel, or glass, or building air conditioning. So to allow us to compare apples with apples, the carbon is lumped together into different packages or modules, depending on when it's emitted. The stuff emitted during the actual construction process, this is you, Pete, before you get the keys, is known as upfront carbon, embodied carbon, or modules A1 to A5. Carbon emitted once the building's in use, once the building is used, there'll be additional little bubbles of carbon emitted when things are manufactured, maintained, replaced, or refurbished. This is known as in-use carbon, or B1 to B5. The energy and water used to operate the building, cooling, heating, toilets, showers, and industrial processes, is, funnily enough, called operational energy and operational water, B6 and B7, and they result in operational carbon. C1 to C4 is the end of life stage, and this includes demolition or deconstruction, transport, waste processing, and disposal. And then stage D covers any benefits beyond the building life cycle, recycling or reuse. And this is where the circular economy comes in. Products used here can approach carbon neutrality in their second life. So overall, buildings contribute to 39% of global greenhouse gas emissions. On average, 60 to 80% of this is upfront or embodied carbon, and the remaining 20 to 40% is operational carbon, heating, cooling, and so on. But the exact split varies depending on location and how the electricity is generated. So Warren and Marnie did an exercise a few years ago to compare the exact same building in different locations to see the effect of different grids. So what you want to look at here is the dark grey bar at the bottom. This is the operational energy, and in effect it measures the amount of carbon emitted by each grid. In Europe, we found it's a 50-50 split between upfront and operational carbon, and their grid is reasonably clean, around 40% renewable. In the US, New York and California are reasonably similar to Europe, although with less renewable energy. By comparison, Hawaii, although that's clearly Australia, there we go. By comparison, Hawaii has a very dirty grid and relies heavily on coal and oil and has a 60-40 split between operational and upfront carbon. And then similarly, Australia has a phenomenally dirty grid, uses heaps of coal, and has a 70-30 split between operational and upfront carbon. So the trend is that the dirtier the grid, the bigger the effect of operational carbon. But in New Zealand, as always, things are just slightly different. So the graph on the left, my right, your left, suggests the energy use of the building is around 5% of the national energy use, but this doesn't account for the construction processes. And when upfront carbon and imported materials are included, as you see on the right, the construction sector contributes to around 20% of the national carbon emissions. But this is still only half of the international average of 39% for several reasons. Our electrical grid is largely renewable, around 85%, ignoring the cars though. We have a much higher proportion of agricultural emissions than most countries, and we have poorly performing building stock and a comparatively benign climate. As a result, we don't heat our buildings to the levels seen overseas. And so in New Zealand, because of our clean grid, the upfront carbon of our buildings has a much higher impact than anywhere else. Essentially then, the fabric first or fabric fifth debate is discussion whether it's better to focus on B6, operational energy use and carbon emissions, or upfront in-use carbon emissions A1 to 5 and B1 to 5. And as you've just seen, the answer depends on where you live. But there's also another factor to consider, and that's time. So this is a well-known graph derived by John Oschendorf of MIT, and the black line shows the upfront carbon that's mostly all emitted at the beginning of a building's life. It's shown effectively horizontally here, although in reality you'd see a few blips when, say, the carpet is replaced or maintenance is undergoes maintenance. The red, yellow, and orange lines show the cumulative operational energy used by low, medium, and high efficiency buildings. And now it would seem possible, and as you can see, the more efficient the building, the less energy you use. Strange. So it would seem possible that the operational carbon of a super efficient building, say passive house with a net annual energy demand of 15 kilowatt hours per metre squared, might never exceed the upfront carbon emitted by constructing that building, and that's the green line. And if you had on-site generation, say passive house premium, wouldn't that just mean that the solution is to reduce operational energy to effectively zero and all our problems are solved, i.e. electrify everything? The blue line. Well, we'll talk about the blue line. In theory, yes. But the upfront emissions of the building are actually baked in as soon as the project starts on site. So in reality, the carbon emission profile looks more like this. One big burp to start with, followed by a long tail of ongoing emissions. I was going to make a note that this was the good news, but I'm not entirely sure that's right. Because this is the bad news. The bad news is this graph from Brand's 2020 study, Zero Carbon Built Environment, #1. And using planetary accounting, it calculated the allowable carbon emissions for the construction sector if New Zealand was to keep to the Paris 1.5 degree commitments. And that's the red dashed line you can sort of see sneaking in the bottom there. So you can see there's a serious mismatch. Even the most efficient builds are more than 3 times the 1.5 degree budget. This diagram shows it a bit more clearly. Between 2020 and 2050, the average new build house contribution to global warming is evenly split between upfront carbon, or materials, shown in green, and operational carbon, shown in red. So in New Zealand, because of our clean grid, fabric first or fabric fifth is not a binary choice. If we're to get to net zero, we have to approach it as both and, not either or. So what to do? Well, this helpful diagram sums it up. Use less stuff. It's from the Institute of Structural Engineers, but the principles relate reasonably well to architecture. So to start doing myself out of a job here, the first thing is to build nothing. There's obviously a moral expectation to allow the rest of the world, i.e. the global south, the opportunity and ability to improve their living standards. So somehow we have to navigate that challenge, and it really has to start by leadership and commitment to zero carbon from the Western world. Secondly, we can build less. We can repurpose, refurbish, and reuse existing buildings. We should be building clever. This is where you guys come in. High performance and low carbon architectural elements. Straw bales, mass timber, and wood wool insulation, for example. Not steel, concrete, and polystyrene. And build efficiently. We shouldn't be building 450 metre square houses for 2 retirees, let alone ones with helipads. So what tools are there to assist us in this? Well, the New Zealand Green Building Council has an excellent sustainability toolbox for both operational and upfront carbon. It covers residential buildings with the Eco tool, Green Star buildings, Green Star communities, and Green Star interiors. The Eco calculator is partly based around the passive house planning package, and it is rumoured that it might become part of a New Zealand building code requirement in the near future. Warren & Marnie and many other architectural firms can assist with Green Star certification. We also all offer a range of standalone carbon assessment services for those who are not going down the full Green Star certification route. These are some examples of the stuff that WAM does. We look at carbon optioneering for facades, structures, and interior finishes. More recently, MasterSpec, in conjunction with brands, have released a new website, the neco2.co.nz, which is, and you have to hold your breath for this one, the National Embodied Carbon and Environmental Product Declaration Repository. It's more useful than the mouthful it is to say. Brands also have a free and slightly clunky spreadsheet, LCA Quick, which allows you to assess your own project if you've been modelled it. Operational energy is a bit more tricky for commercial buildings. My experience is that the services consultants will rightly point out that energy usage is hard to predict because it depends on how the occupants run the building, so they refuse to commit to a figure or provide any guidance. But neighbours have a post-construction measurement system for commercial buildings. This has a sinking lid, so it encourages incremental and continual improvement on a year-by-year basis. And obviously, the passive house planning package is aimed specifically at operational energy and is hence a proxy for operational carbon. But by itself, it doesn't calculate embodied or upfront carbon. There is a plugin, the PH Ribbon, which claims to do this, or you'd have to check that this is appropriate to and able to be set up for the New Zealand market. There's a number of architects and passive house designers around the country. PHINZ have a list for these, and I'll direct you to the PHINZ people here. And although experience in New Zealand is generally limited to residential programs, residential projects, although a few commercial buildings are starting to pop up in and around Wanaka. So there's many additional benefits from either improving the fabric or electrifying. But if the New Zealand construction sector is serious about keeping to the Paris 1.5 degree agreement, it's imperative we treat this as a both and, not an either or. Unlike only a few years ago, the knowledge is there, the tools are there, and all it's missing is the commitment. Thank you.
All right. Good evening. My name is Julie Villard. I am the eco-design advisor from the council. So today I'm going to talk a little bit about what council is doing with regards to fabric fifth or fabric first. All right, so as we know, we've got a climate resilience strategy. This was established in 2000, sorry, I'm a little bit nervous, that's okay. In 2019, we've got 4 goals with this climate resilience strategy. The first one is to be net zero emission for Christchurch. I'll develop a little bit of that. This is just about operational carbon, not embodied carbon. We want to understand the impact of climate change. We want to provide options for low emission economy, and we want to protect the environment. With this, we've got 10 climate action program. They are here. Number 7 is about energy efficient buildings, and that's me, the Eco-Design Advisor Service. It's a free service. So basically the council has a procurement policy, and it's all about finding the right balance between the people, the money, and the environment. And it's not something easy to mix, but basically every single project has its own priority, and we need to identify what they are to be able to achieve it. So emission and targets for Christchurch. In 2019, this is basically a little diagram that show you what were the emission for the district at the time. We've established 2 goals. So you have to think about, we want to reduce carbon emissions for the district and for the council as an organization. Sorry, I'm French, so I stumble on some words. So as a district, basically, we want to be carbon neutral by 2045, and we want to reduce carbon emission by 50% in 2030. We want less methane as well. And then as an organizational entity, we want to be carbon neutral by 2030. So how are we tracking? Basically, this is a little diagram to show the carbon emission for the district from last year report. From this number, this is 12% down from the one from 2019. So we are on track for reducing the carbon emissions. What we can see here is there is a little bit more about buildings. We were at 19%, we're now at like 21. But basically, this is kind of good news. With regard to the council's emissions, so council's buildings, this is the little diagram we get. And basically here, big surprise, wastewater is the big source of emission for us. At the moment, we are rebuilding 2 of the main pump stations, so hopefully, and treatment plant. So hopefully by 2030, this will be reduced significantly. And you can see here that electrification of building is also a big part of it. So how are we tracking? Basically, we're on track for the reduction of the emission of the district for 2045. We might actually achieve that probably 2 or 3 years ahead. With the city, with the building, for the organization, we might be we are on track, but for 2032, not 2030. And the main reason is about like electrifying. I will explain that in a second. So if you want information, basically you can jump on the council website. We've got a climate action page. You can look at how we're tracking. And if you want data, we've got data. So you can go and have a look and see how we're doing. But basically, from a council point of view, what are we doing when we're building? So when we're building new, we're trying to do the best we can with regard to the envelope. So fabric first. This is the new library. It's a 5-star rating building. This building saves 72% of energy for heating just by having a good system in place. Really great. When we build new, we try also alternatives. So this is the St. Albans Community Centre, and here this is a different approach. We want to try to reduce carbon emission on an embodied part, and here we're storing a lot of CO2 in the CLT panels. Different approach, but new building, basically very important to have the fabric first. But we know the future is electric. So when we've got existing building, what do? Well, we're going to slap on solar panels, right? We've got a mandate to put solar panels on all the council buildings. And we started last year with the swimming pool in Hornby. We slapped 625 panels on this lovely roof. And we're saving $90,000 a year, right? So yeah, exactly. So this is happening. We're putting solar panels on all our roof, and hopefully by the time we've done them all, we reach 2032 and boom, we're there. When we do new build, because we're still doing new little build, we don't really build houses. So this one is the Littleton Recreation Changing Rooms. Basically, we're trying also to be as efficient as we can. So we slap some panels, we collect the water for trying to save on site what we can do. So this building hasn't been open yet, but it is already up to being used. So feel free to go and have a look, Littleton. If there is people from Littleton, peace out. I'm from Littleton. Okay, so what to consider? From the Eco Design Advisor point of view, because council doesn't build houses, right? But Eco Design Advisor is about homes. Well, like Damien says, what's very important is what choice you make. You have options about choosing between economy and ecology, and everything that's in your hand. You can choose what's best for you. We have to think about the house as a system, and then so you have to combine the mechanical system you're putting in place, the environment, the building, and you, the occupant. And it's very important to make sure like everything, it's actually working together in combination with whatever decision you have made. Now, if it's not clear enough for you, I've got this lovely little pyramid that explain a little bit how to make the choices. So if you build new, and I'm sorry, it might be a bit different from you guys, what you're saying, but hey, if you build new, you have to think long-term. Most important thing is the site. The second one is the building form. The third one is the building envelope, then the services, then the renewable. Site is key. So maybe the building envelope might be third in this scenario for new build. If you're renovating, different stories, same diagram, but you start at the top, renewable first. Just slap some solar panels on that roof. That's the cheap things you can do to save money right there. Then update the services. Then if you still have money, you can update the envelope. If you can change the form. That will be even better. And in doing something about the site, I don't think people can do much about it, but yeah. So that'll be basically, in a nutshell, basically do your best with what you know. I have a little extra things to share with you about certification matters. So if you build, like me, a very efficient house and you get a certificate, well, now you can have that on your limb if you want to. So it is recorded under your building consent number, and you will have what type of certification you get and the date of it. Here is a typical example from council to try to emphasize how important energy efficiency and good buildings are, and we need to share the love for it. So if you want to know how to do it, you need to go on the Eco Design Advisor webpage. There is a link and an email address. You can send your certificate to us, Passive House, Super Home, Homestar and Green Star, and then get that on your limb. And be quick, because for the moment it's free, but it's not going to be for long. So thank you.
Okay, my name's Jonathan. The reason why I've got 42 on my title slide is what Damien asked me to talk about, which was everything. And wrap up all the speakers' content and then add a case study of my own house. So I put the answer to everything. We'll start with that. But we're going to do a bit of a recap. And I've written some slides for this, but I might do it a different way. And we're going to go around each of the speakers and try and remember what it was they said. So if 42 is the answer, what did they ask? Anyway, I should introduce myself. I'm not an architect, I'm not a builder. I'm actually an accountant, risk manager, project manager, put in IT systems, but probably the two logos at the bottom might mean more to you. I worked for an architecture firm in Wellington and a consulting firm in the UK called Beyond Carbon. Worked on a couple of buildings for Oxford University and one for Exeter University doing carbon modelling. So I come from an energy perspective, kind of. I was the client, and that's how I got into this, working for Content Energy before I got to build my own house. So I could go through a whole load of stuff, but I'm sitting between you and a lot of food and some wine. So I'm not going to do it in detail. So my first request is be a critical friend, not a skeptical cynic when you ask those questions later. And a reminder that we used to think cigarettes were good. And the doctors used to say this, but measure of intelligence is the ability to change your mind. So here goes. So to recap, Damien said Passive House was a way of getting a comfortable home. He talked about efficiency. Chip in if I miss anything. Paul said there are planetary boundaries, so there's a wider scope beyond just the house, and we've exceeded most of those planetary boundaries. Kind of do the best you can. Mike said electrify everything. So, and electrify everything saves you carbon and saves you money. Pip said that it isn't just when you use energy, it's not just how much energy you use, it's when you use it. And if we use more energy, they invest in the grid. That's a charge to you and more carbon. And then Julie said, beyond the scope of your house is the community. So as soon as you build a house, they have to do water treatment, fresh water, build buildings, and there's carbon associated with that. And building better helps them. Now, and Chris talked about carbon. So, shit, as I model carbon, so I should get something clean. So, talked about upfront carbon and operational carbon, and that if we assess buildings in New Zealand, I think brands set a carbon budget based on 2018 data. They published in 2019, and they said for a single family home, we would blow that budget by 2024. So the amount of carbon that we're allowed to build the next house is 0 kilograms. It's not a good place to start, is it? So how do we do this? We're looking for a solution that includes sufficiency, so we're not building 350 square meter houses with swimming pools, and because there's a lot of carbon. Maybe some smart density buildings. We want them to warm and dry. We need to be low carbon. We need to be demand flexible, use less energy, be all electric. And we've got to be able to afford to build them, which will be a bit nice too. So I've got slides on all this, so I'll get to my house. So this is talking about solutions. So if we're looking for a holistic approach to designing and building a building, we don't necessarily need to invent the wheel. We don't have to invent a new building standard. A group of people in London got together, London Energy Transformation Initiative, came up with a climate emergency design guide, also a retrofit guide. So if we look at the building in the middle, it has to be a combination of addressing embodied carbon, that's the red stuff to the right. The yellow stuff is operational energy, future heat needs to be decarbonized, demand response, renewable energy. So that's the link to the design guide. We could just use that. However, it's based in London, isn't it? But we could very quickly just adapt it to New Zealand. The other possible solution is a future home standard in the UK, and just a couple of screen prints from the left-hand side, all electric, low energy demand with heat pumps and solar. From 2027, I think all new homes in the UK have to have solar on the roof. Homes have to be able to demand shift, which is Pip's point, use the cheaper and cleaner energy. So future building standard could be an option if we wanted to adopt that in New Zealand. And then on to what I did. So is it possible to do everything? So this is Passive House Premium. It's supposed to be hard. It isn't. You saw from my introduction, I'm not an architect, I'm not a builder. I built the first Passive House Premium house in New Zealand, and it's the 15th in the world, and by far the most energy efficient building of its type. So this is what it looks like. So a passive house, it's a rectangular box, 2-story. Ironically, the structure is German oak, because we all know if you import it from overseas, it's probably about half the price than New Zealand. So that's German oak imported because it's cheaper than New Zealand timber. That's what it looks like inside. It's all electric. There's an electric car. It's got a heat pump. Controversially, the integrated heat pump cylinder is inside the house. We've got a battery and solar, and we've got ground-mounted solar array. So ground-mounted solar array, because it stays cooler, will generate more energy. And this little box on here is from the Tesla Powerwall. So it's a bit out of date, but since building the house, just the solar and the battery have saved me $28,000. That's not from switching from using gas to using electricity. That's just simply from that ground mount array and that battery, either exporting power to the grid when it's the most expensive, I mean, the best return for me, or using the energy in my house. But passive house is building physics. So it's kind of like your own laboratory. So I didn't stop there. So on the left-hand side is the Carbon Net Zero Institute set up by Octopus Energy. It's an assessment tool to assess demand responsiveness of your building. What are the measures you have? Pip mentioned the thermal envelope to store heat, store energy in your hot water cylinder, chemistry, battery, etc., etc. I ran my house through that tool, and it's 100 out of 100. So I'd recommend, if you're looking at energy efficiency and want to assess demand response, there's a tool. The Chalet Relay, that blue box, is about $80. That permanently shifts the hot water cylinder away from expensive energy, so it can only run between the hours of 11 and 5 o'clock, and it doesn't touch the power. So that's also the time when I'm generating. So I'm permanently shifting. The nice new solar array, which costs $3,000 and generates power at 2.4 cents a kilowatt hour, could be exported onto the Aurora network at 60 cents a kilowatt hour at peak time. So that's how you can make money or save money. What it's done is, these are the two graphs. So graph on the left is August, winter 2024, and with that extra oversizing of the solar array, I've basically 38% more power generated, and that's $1,000 worth of panels. So solar is just so cheap now. And the box in the middle is turning your EV, so not just sending power from the grid into the battery in the car and driving around in it. That takes power out of your car, runs your house off it, and exports to the grid potentially to get 60 cents a kilowatt hour. Now, that's been talked about with electric cars for some time. That's currently being trialed in Australia, and the effect in Australia makes your EV half price. Australian consumers can make 4,000 Australian dollars per year selling power back to the grid from the car battery. So that's being approved by Aurora, the Lions company in Otago, and watch this space. The little diagram on the right is some building work that we're going to do on the house. So what's the future? You can do fabric fifth, as being mentioned, is basically retrofit, but zero bills is the equivalent for new buildings, and it's an Octopus energy product, and they give you a guarantee you get no power bill in UK 10 years. They're already doing that in New Zealand on North Island, power generation from solar with a battery, guarantee you can take to the bank, no power bill, 5 years. I've worked it, so Tim Ross, who's an architect who lives in a passive house co-housing project in Dunedin. Octopus are running his project for the 26 houses through zero bills right now to size the solar array and batteries. E-House, who build passive house around the country, are assessing zero bills homes. The medical is a medical center in Queenstown, zero bills for a medical center. And that's with solar panels on the lease building and giving the system to the landlord. Schools currently working with a professor at University of Canterbury to make a school no bills. I'm not going to play the video because it sounds like an Octopus ad and I'm already wearing their socks. So I'll explain how it works. They take the house, they drop it in the grid, they forecast ahead for the next 5 or 10 years, what they can make from selling your power, what they have to pay to buy the power that you'll need, cover all the fixed charges from the Lions company and Transpower, and give you double the allowance for what you use today. And then they issue a guarantee, no bill. So what does it look like? A zero bills home. It has solar on the roof, it has a battery, it has an EV charger, it has triple glazing, upgraded insulation. Passive house people sing out if any of this sounds familiar. Mechanical ventilation with heat recovery. But critically, it also has smart tariffs and smart management. And it's being turned into a building standard in the UK. So property developers are signing up to have buildings that are affordable, low carbon, no bill, comfortable. 42, everything. So passive house, to summarize, is a building, it's building physics. It's neither good, bad, but it now enables you to optimize how your building works. The gotchas for New Zealand market is, what does it cost to build? We tend to have to import, we do make some windows here, but we tend to import them. We have to add more fabric that has a carbon hit. And of course, to Mike's point, everything is better if you make it electric because it's cheaper to operate and lower emissions, so that's with renewables. And don't go adding a swimming pool to your house and have some sense of size and sufficiency. That's me. If you want to ask me any questions, any of the panel, come up to the panel afterwards.
Cool. Thanks, Jonathan. That's seriously interesting, and all the other speakers, man, the information that is we've learned tonight, yeah, it's incredible. the last thing you guys want now is a pitch for me to tell you how amazing our heat pumps are or what we do in that sense. So I thought quite long and hard about how to approach this, and I'm in a bit of a unique position here because I recently completed the Passive House consultant course, so I'm qualified there. But I also work for Warmth NZ, who specialise in high efficiency heat pumps, hot water systems, and heat recovery ventilation systems. So I thought about this and I thought, let's humanise it a little bit, because we've had a lot of statistics and a lot of specifications and things. I thought I'd pose the question, and it's because it's really what we do. We deal in comfort, and I kind of thought I'd ask, what is comfort? And we tend to look at comfort as a situation of, is your house warm and comfortable? And the reality is that, and from a passive house perspective, we would say 20 to 25 degrees year round, and only overheating maximum 10% of the time, or going over that only 10% of the time. And that's a good box kind of definition for a temperature comfort. But the reality is that it's actually a bit broader than that. We can look at comfort in a home from, is a home comfortable from an environmental perspective, as we mentioned earlier? So do we burn lots of fuel to keep it warm? We can look at comfort in the home from a health perspective. Do we have internal moisture problems in our home? We actually saw lots of mould in the roof spaces. It happened in the last 4 or 5 years since a certain code change, because houses have become more insulated and they don't have ventilation. So are our homes comfortable from a health perspective? CO2 is another one in that zone. Are our homes comfortable from a running cost perspective? So you would argue that if you had a house that is really a nice, beautiful home, but costs a lot to run, then some people would argue that it's not comfortable financially to run. I would also ask, are our homes comfortable from an aesthetic perspective? And that's where there's lots of architects in the crowd tonight that I would say, that's where you guys come in. We need you guys to build beautiful homes, and there's a lot of studies on mental health, people loving where they live and being comfortable. So I guess what I'm saying is asking is, what's the point of all of that? And we'd say that being comfortable in a home is really a fine balance of the lot. But what we need everyone here to do now that we've learned about this is actually advocate for it. So we need everyone here now to hear that's been said tonight and spread the word. And that's what Warmth is really passionate about. Warmth can help in that regard. We're here to help, and we do that via hot water heat pumps, specialised air to water heat pumps, underfloor heating systems, and heat recovery ventilation. And there's a couple of our ventilation systems, Passive House certified as well. That's really about it for me. I'm not going to bore you with specs and stats and things. The bottom line is that we're here to help and enjoy the food. Yeah, and definitely come and talk to us later. So yeah, I'm going to pass you on to Tom now.
Kia ora. I'm Tom Stubbs from the Think Solar Group here at the Christchurch plants in Christchurch. I'm going to get quite narrow into the thinking here and give you some tools on how to think about your solar system and some decisions you might want to think about when choosing provider, products, and the service you might be after. And so Within the Think Solar Group, we currently have 6 branches. We're not just here in Christchurch, you can see them up there, Wanaka, Dunedin, Queenstown, Nelson, Timaru. This all started off in Wanaka in 2013 with Dean Dunning, and then we've grown to these branches all around the South Island. Now, some of the key sort of values we believe in, and we've tried to streamline for customers. Before I actually go into this, raise your hand if you've either considered solar PV or you have solar PV on the house you're in right now. Right, yeah. And then leave your hands raised if that was a great experience for you. Oh yes, that was sort of 50% of the room and then went down to sort of 50. Yeah, so it's a common feedback for us that the journey's quite interesting, from confusing to quite sort of disruptive from a provider point of view, from provider to energy retailer to sort of what products you might install at the end of it. So we just tried to streamline it from the customer experience through to empowerment and education and just bettering our environment. And I'll try and break them down briefly. So customer experience for us is basically listening. It's not just giving you a standard size of 10 panels, 5 kilowatt inverter, da-di-da-di-da. It's actually listening to what you want and what the future might look like. So is that incorporating an electric vehicle in the future, et cetera, et cetera. And then delivering on the install. So all our branches have our own install team, our own design team, and then to be able to support that system afterwards, which is really important. So you've got someone to phone at the end of it. When the system's been installed and you're asking questions, you've got queries, who am I phoning and where are they? Better in our environment. As you've just seen, we've got 6 local branches, so we're pretty isolated to the South Island currently. So we're local. And we choose our equipment wisely as well. From a bunch of different perspectives, we probably install anywhere from 3 to 5 systems a week here alone in Christchurch. So we're exposed to the market quite often in terms of new products coming to the market. And we do a lot of testing to make sure that those products are going to perform like we want to, and obviously for the end user. And then we're obviously passionate. This is all we do. We live and breathe solar, battery, and EV charging, and make sure the customers get their great experience with that. And then sort of lastly in our sort of 3 areas is education and empowerment. And this goes, it's quite a broad spectrum, I suppose for us, because it's empowering the customer to have the tools to make the right decision, whether they want to work with us for different reasons or they want to go to a provider, but it's giving them the tools and giving them the education and the tools they might need. And this might be from a beginner to an expert. And what I mean by that is there's some people on these panels who've got solar and they've probably got a really good understanding of it, but then we might have some stuff that maybe just gives them an extra layer of advice on that particular topic, or they might be a completely beginner and they're starting from the early stages, and this is a couple of year process from building a passive house and then potentially even retrofitting that solar to the passive house well down the track. So it's quite a broad range, and we just try and facilitate that journey for that customer and give them the best experience they can. How you can reach us is for a few different platforms. Like I say, we're local in a bunch of different areas. So in person, on the phone, and through obviously online platforms, there's lots of places to reach out to us and get our advice. And we're always willing to have a yarn about any of these types of topics. That was about it for me. The last sort of comment for me is time is now. And I had a customer that did a case study for us recently, and he just said, just get on with it.
Thank you very much, everyone. I hope you all guys found it as entertaining here. Yeah, I appeared again. Anyone who has question, please raise your hand. I'm going to come to you. If you can have a couple of minutes to think of it. I'll have a few of my own. Or I can ask my own questions directly to all the speakers afterwards when we have our little receptions. Also, when we do proceed to the reception, feel free to reach out to Marcus and Tom to talk about the specifications that they kindly omitted during their presentations, if you're interested. Okay, so gentlemen here, you were the...
Yeah.
By the way, hold the microphone properly so that people who are online could also hear us very well. Thank you.
Right, this is to the electric cherry champion we've got over there. Fantastic that you want to electrify New Zealand. I just got a couple of questions regarding that goal. Number one is the manufacture of all the panels, batteries, etc. The fossil fuel that it takes to make that overseas. We're a long way down at the bottom of the world. The cost of that, the reliance on fossil fuels to make all that, the end of year or the end of lifetime, what we do with it, also the carbon it uses to get here, and the cost of it. So in an ideal world, I would like to see that the solar panels, batteries are manufactured here in New Zealand, so that employs people, where at the moment, a lot of that manufacturing in New Zealand is thrown out the window and we're just importing. What's your answer to that?
There's a lot to unpack there, but no, we'll get started. So the first thing is it's really important to understand that every single purchasing decision we make has externalities, right? I'm going to use cars as an example just because I know the numbers off the top of my head because I was reading up on them again today for another discussion. If I was to click my fingers overnight and electrify all the cars in New Zealand, we would need 800,000 tonnes of batteries, right? That is a significant amount of materials. But it's important to contextualize this. We import 3.1 million tonnes of fossil fuels each year to run our fossil fuel cars. So 800,000 tonnes probably every 15 years or 3.1 million tonnes every year. So when we look at it from like a tons of materials consumed perspective, and this is not talking about end of life, this is just over the lifetime of a vehicle, a fossil fuel vehicle will consume its weight in materials every 18 months and produce or double its weight in waste every year. So you're probably looking at 400 kilos of additional material in an EV compared to a fossil fuel car when it is made, but you are talking about thousands and thousands of kilograms of materials avoided being consumed over its lifetime. So that is a really important thing to understand. At the moment, one of the things that I find most shocking is that 40% of all global sea freight is in the transportation of fossil fuels. Right. And I can't remember what the stat was offhand, but it was something along the lines of one container ship full of solar panels was about, I think it was 60 liquid natural gas tankers worth of gas. And about 100 ships worth of coal. So that puts it all in perspective, right? Yes, we are at the bottom of the world. Yes, it requires shipping. So, but it just requires so much less materials overall. When it comes to end of use, this is a real problem that we have to figure out how to solve. I've been doing a lot of work with PHINZ Recycling in particular, which is they can now pull 98% of materials back out of solar panels here in New Zealand, which is pretty cool. We can recycle certain types of batteries. We can recycle lead acid batteries. We can recycle nickel metal hydrate batteries. Why? Because we have the manufacturing in New Zealand to take the feedstock. Right. When it comes to lithium iron phosphate batteries, nickel manganese cobalt batteries, we cannot recycle them in New Zealand. One, it's very, very difficult to get insurance on a shipload of secondhand batteries to send them overseas to recycle them somewhere else. What we do now is we create this thing called black mass, but it's more expensive to create black mass than it is the commodity price for black mass when we export it overseas. So yes, a massive opportunity for manufacturing in New Zealand. I'm skeptical on it just because the Chinese flywheel on the stuff is moving so fast now and the prices continue to plummet. I struggle to believe that we will have a future opportunity to manufacture in New Zealand of new stuff and using that feedstock. But I do think there is an awesome opportunity with refurbishing or reusing a lot of this material and creating a lot of secondhand markets around that. Car batteries, for example, moving into homes would be awesome. I could wire one up tomorrow. The problem is I can't get insurance for it. So there's a lot of human-made barriers at the moment that are stopping a lot of that stuff from happening. Number one thing, it's not perfect. It's 1,000 times better. Yep.
Kia ora, my name's Gavin. The question for Pip. Just in terms of what is Orion doing for allowing like vehicle to home, vehicle to grid?
Yeah, so actually we've just finished a big vehicle to grid study and pretty keen to get into trialling what that can look like on our network. I think to Mike's point, there's often a lot of regulatory stuff that we have to navigate through that, particularly around safety. But we're already doing some trials around what we call distributed energy resources. And so that includes everything from solar panels to batteries to EVs to everything. So there's already some trials underway on various forms of DER and what that can look like in a community sharing kind of context. So pretty keen to get into that vehicle to grid area as quick as we can, because I see that as being like just such a awesome opportunity around energy affordability, but actually also resilience. And I know that's something that's often top of mind for people having gone through earthquakes and that kind of stuff. It's actually having a mobile battery is just a huge win. So pretty keen to get into that.
Thank you, Pip. Anybody else? Yep.
Thank you. I'm accountant. I forget your name. Sorry, Jonathan. Thank you, Jonathan. So if you're keeping the North Star being zero bills and comfortable, between load shifting, energy efficiency, and generation, what do you think is the right mix? Like the cheapest way to get that perfect?
It's a great question because it's the kind of subject of what Fabric Fist trying to drive at, or zero bills homes. And so I think we've sort of seen that first step, whether if it's an existing home, put solar on. You've got to, if it's a building, it needs to be comfortable and warm, a sort of minimum standard. And then when you start spending dollars to conserve energy, we now have to put it up against spending dollars to generate energy. So if you can basically put if a power station on your roof is $15,000 and a CO2 hot water cylinder is $10,000, the solar wins in terms of cash. So I would say this balance between active systems that are electrified and passive systems where you put the improvement and the investment into the fabric of the building. Because we don't manufacture, we can get trees and some insulation here. The costs are very high if you go passive house. So for my own home, I could afford to build it. That's importing the kitchen from IKEA. That's importing the solar panels from China. That's importing the cladding for a third of the cost and buying it in New Zealand. That's importing the German oak because it's cheaper than having timber in New Zealand. That build, you insure a house for its rebuild cost, 2.4 million. I couldn't afford to build that house. So it's a real challenge. So if you have to dial it back from passive house standard, then Damien mentioned low energy build. So if you look at standards in the UK, like the LETI, or or in Scotland, they've just put in that the MPs in Scotland got together, 98% of them lifted the building code to basically passive house equivalent. Now, I probably shouldn't say something negative about our MPs, but would 98% of our own MPs vote for their own pay rise? So that's the Scottish Parliament saying, we're going to go from building code to improve the health of our buildings for health of our occupants. And they went to passive house equivalent. Now, 15 kilowatt hours is passive house, premiums below 12. UK building code is 30 to 40. If we modelled a New Zealand building and you wanted every room to be warm, it'd be like 122 kilowatt hours per square metre. Building code in UK, 30 to 40. Building code in Scotland, 20 to 30. That's minimum standard in Scotland now. So we have, if we don't drive through compliance, higher standards, higher volumes, the price stays high. So my honest opinion is, you know, if you can afford to build a passive house, do, but as a scalable solution for most New Zealanders, it might be beyond your budget. And then you go more active systems and then fuel them with cheaper electricity by having solar on your roof.
Do you have any follow-up?
No, thank you.
Thank you, Jonathan. Anybody else?
Hi, my name's Simon. Question for Mike. So I build high performance houses, and one of the first things people will often say when they come to me is, "Oh, we want to have solar panels on our house." And I've always said, "Well, hang on, let's focus on making the house so it doesn't need energy before we focus on generation." And if we look at Julie's little pyramid of how she had arranged that stuff, it's kind of, you know, the same kind of principle. I'm just interested on your take on that part of the argument.
Yeah, this is where the nuance gets really interesting, right? And it's probably following on from your question as well. I think we can split it into three key categories. Those New Zealanders that are looking to build a new home, which is obviously what we can talk about in a moment. We've got those New Zealanders that are living in unsafe, unhealthy houses. And I think that is a very, very different approach that we need to be taking to making sure that they live the standard Kiwi lifestyle, right? And I think that a lot of that comes down to fabric improvements over any form of electrification, in all honesty, just making sure that, you know, they're not seeing the stars when they go to sleep at night is probably a damn good start, and that we replace tarpaulins with actual roofs. And then you've got everyone in the middle who owns their own home. And what I would love the community around electrification and building design to is actually come together and sort of sequence that. Because I think putting ceiling insulation in for a few $1,000s is probably an amazing return on investment from a health, a comfort, and an electricity perspective, right? I think putting floor insulation in would probably do the same thing, but then it gets very, very murky very, very quickly if we don't look at all options on the table. And I think it's very important to understand what exactly the household's goals are. If it's a climate goal, well, then it's electrify all the machines and leave it at that, right? If it is a energy system goal, which I don't think most New Zealanders give two hoots about in all honesty, but if it is an energy system goal, then it's probably putting a battery in the garage. If it's a resilient goal, it's definitely putting a battery in the garage. If it's ROI and you're living a reasonably comfy lifestyle, then it's 100% solar panels on the roof, right? And so I think there's probably a couple of other motivations in there, but you roughly get the idea. I think the most important thing when we're looking at building new homes, and if we're in a position where we're able to afford to build energy efficient homes, 100% we build an energy efficient home because it just makes sense to do that, right? But I would say that not that I have any say over the passive house standard, but passive house premium should just be the standard, because for an extra $20,000, you can put solar on the roof. And for the typical home in New Zealand, it will return $60,000 by the end of your mortgage, right? So you will get savings from day one. What is missing from all of this is the car, right? And every single car by 2040 will be electric, and 90% of them will get charged at home. And that is where that gets very interesting. I think from a vehicle to grid perspective, I think from an economic perspective. So I think the short answer is go hard on your energy efficiency, but remember at the end of it that spatial heating is probably only 15% of someone's energy use. And so there is just so much more to this now. And, you know, everything, when you're building a new home, you're not just financing the thermal envelope, you're also financing all the appliances that go in the home. You may even be financing on the car in there as well. So when we look at that, we have to look at our energy subscriptions that we pay to energy landlords versus the energy that we can create ourselves on the roof, and how we can store that. Because you're right, there are lots of different ways of storing energy that just isn't in batteries. So long story short, yeah, like and that wasn't a particularly short answer, I do apologise, is definitely the argument for both. But what I really want the construction industry to get over is this idea of embodied carbon inside solar panels, and that's a reason not to do them, because they save so much carbon over their lifetime and so much money over their lifetime. And simply put, a ton of coal every winter, which is remarkable. Yeah.
I could be a little bit biased there as well, but I reckon the last 8 new builds that we've been involved in, the customer has literally gone to the bank and been able to finance the cheap loans. And so they're building a house, whatever mortgage rate they're going to have on that, but then the solar comes away at sort of 1% or 0 interest. So no brainer.
Thank you for that. Damien, could you look at the chat, please? And those who are willing to ask questions in the audience, could you raise your hands in advance? I'll come to you, and so that we can understand how many questions we have in the queue. Thank you.
Just before I start, we've just been talking about cost, but I remember a time when double glazing was too expensive because everyone had single glazing, and then thermally broken, double glazing was too expensive. So the more people do something, the cheaper it becomes, and more it's accepted, the cheaper it becomes. So it comes back to the cost of choices: price, cost, value. I've got a couple of questions from the chat. I think one's sort of self-answered, but Mike wanted something spicy. Jazz sums up, so here we go. Mike, Rewiring Aotearoa has lots of money and very smart people, resulting in very effective campaigns. Not me personally, the speaker, I've attended a community RA presentation and looked at resources. They are impressive, but why no mention of the benefits of improving the energy efficiency of homes, either retrofitting or when building new? Why is that? It matters because your organisation's resources risk eclipsing the efforts of those campaigning for a paradigm shift to more sustainable transport, i.e. getting people swapping car trips for public transport, bikes, walking, etc., and radically more efficient homes like Passive House. And that's a pity. Can we do all want to make shit better. Can Rewiring Aotearoa be less siloed and more collaborative?
Yep, that is spicy. And the short answer is effectiveness comes from hyper-focus on a particular thing. Now, what we are hyper-focused on is electrification, because when we look at the climate crisis globally as a whole, about 85% of emissions are energy-related emissions. Every country in the world is going to have to go through this energy transition at some point. But why we are heavily focused on electrification in particular is because New Zealand's probably the first country in the world to hit what we call the electrification tipping point. What that means is you are never better off buying a fossil fuel machine in this country again economically, right? So even though electric vehicles, as an example, are more expensive than fossil fuel vehicles, if you finance them on your mortgage at 5%, you will be paying less over their lifetime than if you bought a fossil fuel car and instead paid that finance through a litre of petrol or a tank of petrol every week or so. So then it does get really interesting, right? When it comes down to things like energy efficiency, which, obviously you're talking about, and other mode transport shift. There is no way that I am arguing for less efficient homes, and there is no way that I am arguing for more cars on the road. What we're simply saying here is, if you're going to build a home, then make it electric, and probably the cheapest thing is putting solar panels on the roof. If you have a retrofitted home, well, let's together work out the sequence, right? Let's work out what you need to do. If you've got $10,000, what's the best spend for that money? If you've got a little bit of space left on your mortgage, is it worth continuing to pay the mortgage down, or is it worth saving on the cost of living by looking at some of these upgrades? We're not getting into building code because the hyper-focus for us is on electric machines and then powering those electric machines with energy that we can create ourselves in New Zealand. Or more importantly, it's about arguing about moving off Saudi Arabian molecules and onto New Zealand homegrown electrons, preferably on your own rooftop. When it comes to mode shift, that's the same thing again, right? When you think about it, of course, like biking everywhere is by far the best thing that you can do from a climate perspective. But the issue is getting New Zealanders to bike everywhere. And we see, like, Christchurch is an amazing city for mode shift and active transport, but there's still way more cars on the road than there is bikes. Now, biking is a hell of a lot cheaper than an electric vehicle. So I kind of feel like the price point is already there to be able to argue with people that are inclined to ride bikes that actually riding a bike is probably a far smarter purchase than buying an electric vehicle. But I think we have to be pragmatic here, which is most New Zealanders drive cars, and we do not have time to build our way out of the climate crisis, and we do not have time to create an economic revolution or create a transport revolution in order to solve climate. We have to do everything. Now, if the person here can convince someone to hop on a bike instead of buying a new car, then power to them, go for it, right? Most people, I think, are going to be buying a new car at some point, or buying a car new for them at some point in the next 10 years. And as a result, we need to make sure that if those cars that do get purchased, every single one of them is electric. So we can probably both agree at that point that when there are new cars that come onto the road in New Zealand, they need to all be electric. That's something we can probably all agree on. And the second thing comes to, well, there's 2.2 cars per household. We have the highest rate of car ownership in the world. Our cars' average age is 14.8 years or something, and the average age they get scrapped is 18 years. So there's plenty of opportunity for us to both electrify the cars that are going to remain on the streets for the next couple of decades and remove a whole bunch of cars that we no longer need. And I think they both just work in parallel. I do not in any way go out and promote we should have more cars, right? If anything, 100% we should have less cars. But if you're going to buy a car, it needs to be electric. Yeah, that's probably focus is probably the big answer there to be effective.
Doesn't it come back to low-hanging cherries? Indeed. I think the second question, I think we're all on the board where it's not fabric first or fabric fifth. It's fabric first and fabric fifth. So fantastic presentations all, thank you. I agree that everything should be electric. However, if we build buildings more efficiently, smaller, less complex, then they will use less energy and require smaller systems and heating and cooling, etc. Plus, there will be more energy available to power everything else. So efficiency first, and so fabric first, in my mind, should still be the primary focus alongside electrification, not just adding generation to cover higher use. Yeah, was it that? Leave it there? We agree.
Anyone else? Any questions? May I have one? Pip, what do you want to say?
Sorry, just to follow up on that. So we've got a few different future energy scenarios which are available on our website if you're interested. But just to call out two in particular, one of them is what we call our consumer and place-based transition. So that's where you have efficient homes, you've got solar panels, you've got storage, and it's all working together well. So you could argue it's a little bit of a rainbows and unicorns one, but I really like it and we're actively working towards it. We also have what we call our system transition, which is where nobody holds hands and we just try and build our way out of it. And that is an increase in 40% of our peak load, and that is a significant amount of electricity. So if you consider that every megawatt hour costs dollars to our community. So as soon as that goes up, the cost to our community goes up and the cost of generating to serve that goes up as well. So just to kind of confirm it is everything all at once.
Pip, follow up on that from me. Do you see at this point in the nearest future where the energy efficiency upgrades become necessary before we have to overbuild the system to service that 40% peak that's not there otherwise?
I think we're kind of in that point now. So it does definitely need to happen. We definitely need more solar panels. Like, I absolutely agree, we need to electrify everything. But yeah, that efficiency does also need to happen now. And I'm really, like, I was talking about this the other night, but it was like in England, it's so basic, but they've got their home star system where it's like, how energy efficient is your home? The same as you've got an energy efficiency star system for your appliances. That absolutely should be a thing. It's just a no-brainer. And yeah, I get so staggered by anyone that argues about changing regulation to actually improve the building envelope efficiency and improvement of, because the economic payoff for the inhabitants and health benefits and all that kind of thing associated with, I know people don't care about system costs, but when you think about that kind of thing, it's just such a huge benefit overall to the system. It really is just a given.
Yes. And one of the clear things, if we're talking about energy system benefits, which is about lowering the costs of our power bills for the poles and wires, which Pip looks after, or the generation, the simple thing that we can do is put a battery in a home. The moment we put a battery in a home, it removes that home from peak. The majority of the expense associated with peak loads is residential heating. Right, so that is one way that we can do it, which is really important. Why we don't just think about the energy system when we do this, we also think about people's costs. We are now at a point where financing solar and batteries is cheaper than the delivered cost of energy from the grid, and it's only getting cheaper, and the grid is only getting more expensive. So that gap is widening. The issue is, and why a lot of people think that I'm not pro-grid, I'm very, very pro-grid, is that the final 5 to 10% of the energy that we need is the most expensive form of energy, and that's what the grid can deliver far, far cheaper than us banking more and more batteries in our home. It is also where energy efficiency really delivers, right? So that's a sort of big thing that we sort of need to keep in mind. But from an energy systems perspective, if we're looking at what is the cheapest thing for building out our energy system in the future, is 100% putting batteries in homes. Simple as that.
Thank you. I have maybe one last question on meta level for each speaker to say the final word and closure, and then we're going to have our reception. So the question would be, so that we don't have to choose fabric first or fabric fifth, do you see any market circumstance, behavior, anything else that you can choose from the remaining fabrics, or otherwise your personal opinion that could get us closer to that comfortable living in the decarbonised economy of New Zealand? That would be a question to each speaker, and we're wrapping up. Thank you.
I think at government and local government level, we need to find very simple ways to incentivise the people that are coming through the doors to put consents on tables to be going, that's Faust Premium, that's what I'm building. And the council go, yeah, great, here's a tick.
All right, for me, it will be, Mike mentioned many times that if you've got an electric car, people plug it at home. So just go to a bloody dealership and just try an electric car. See how much fun it is to drive, first of all. And then after that, just do the math of how much kilometer you can do with $3, right? Because I've got an electric car, an electric car home. We switch it from petrol to electric. It was $30 for 100K to $3 for 100K. It just makes sense. So have fun driving your next electric car.
We are in this mess globally because behavioural change has failed. And so the short answer is that we just need to figure out how to support people's lifestyles that they want to lead in a much, much cleaner way. So fabric first, fabric fifth, well over behavioural change, in my opinion, because people are going to continue to do what they do. We do not have time to change everyone's behaviour in order to solve the climate crisis. We have to do it by fixing energy. And I guess that's what we're all about.
I'm going to go in pretty niche on this, but to your point about the failure of behaviour change, I think there's still room for some interventions there, but I actually think that attaching dollars explicitly to the behaviour that we want really needs to happen. And a little plug for the work by the Centre for Sustainable Finance and the Sustainable Taxonomy that they are producing for New Zealand. So it is very niche, but actually that's where you start to drive change, because if you're having to report on the impact you're having in your balance sheet and you're mandated to do that, and then you start to have to air your dirty laundry about what you're not doing and what you are doing, I think that's when you'll actually start to see things shift. So yeah, and also opens up lots of new markets. So that's me.
Okay, I'm going to say energy modelling. So if you traditionally build a house, you move in and winter arrives, you get a power bill. And if that's the first time you realised, whoops, you should have built your house differently, it's a bit late. So, you know, if that power bill's in Queenstown, it might be $800,000. It's a bit late. Well, when I say late, expensive to change and hard. If you're going to retrofit a home, energy model it. So basically, while the design for the new building is on paper, or the design for your retrofit is on paper, assess what the performance is going to be and predict what it's going to be before you build it. And then you can you have a more informed decision making. Is it better to upgrade the windows? Is it better to add some more insulation? Should I install solar? How will that perform? How much will it generate each month? So I would say for a very small fee, energy model, and then, if I'm allowed to, a blower door test. So when you build a house, basically, when you build a new house, typically all the air in the building that you heat up in winter escapes 5 times per hour. So then you have the job of heating it up again to try and stay warm. For a very simple, it's a half day, mount a fan in a door, pressurize, depressurize the building and get a result. You get a very good indication of, well, it's a very good indication of a quality build. So builders that do this all the time will get very, very, very good results. Not 5 or 6 air changes an hour, 0.3. My house, which is the first one I did, 0.13 air changes an hour. So the house gets warm by the sun and just stays warm. So considering retrofit or a new build, energy modelling and blower door test.
I'm a big fan of home energy rating tools. So making that as a standard when something's built, and we're not just talking about a calculator that gets filled out that we tick some boxes, but making sure that when a home is built, and even existing homes have energy ratings on them, because that puts the power back in. Whoever's buying that home, whoever's renting that home, can actually see what that energy is, how healthy that home is, and then that way they can make an informed decision based on either ROI if it's building, or actually how that home is going to perform. So my biased hat on would also say, buy a really high efficient heat pump, come and talk to us.
Totally plugging for what we do here. Some more mass timber buildings would be great. Energy modelling. My presentation basically sat on the fence because I think we've got to do both. We can't just electrify our way out. We can't just fabric our way out. And if you fabric the wrong way, you're going to emit too much embodied upfront carbon, and you'll break it anyway. So it's a very nuanced argument, and it depends on your circumstances.
Mine's quite broad, and I think it's quite challenging. But I think it's going to take everyone to be brought along on the journey. And so for majority of my time surveying customers, well, I wouldn't say majority of them, like Pip said, they can just afford it. But there's also a small amount of people that just can't afford it as well. And so I think it's the presentation with it is the empowerment and education to try and bring everyone on the journey to make everyone's lives in the community better.
I agree, Tom. We're all in this waka together, so getting everyone involved. For me, a couple of years ago, I was in a passive house conference in Wellington. We had a morning talking about climate change. It was dire. We were just about ready to jump off something. And a little Canadian guy got up and talked about sufficiency. about having just enough and no more. And I think we need to sort out what we actually need rather than what we want, and concentrate on what we need. If we concentrate on what we need and have just enough, we'll have just enough of everything. We'll have our low power bills. We'll have all the things we want without all the lavish extras that we don't really need. I know the saying is, he who dies of the most toys wins, but I think we're past that point now.
A round of applause and off we go. Thank you, everyone. Please join us here, and you can probably approach some of the speakers who might be staying. Mike nods at me, so right. More electrification coming. All right, thank you, everyone. Please come down.